So, hello, I am Valentin Zablotsky, and I am represent analysis of technical characteristic of temperature sensor of the design of medical thermometers. You can see me?
Yes, we can see both you and your report as well.
When measuring temperature, an objective assessment of the quality of measurement devices is carried out according for the following main indicators: sensitivity, range, accuracy, age of calibration, stability, frequency range, absence of noise and on-end signals, and ease of use. The purpose of the article is to analyze the quality indicators and the characteristic of temperature sensor based on semiconductors, diodes, and transistors, and formulate conclusion and recommendation for the practical use in the manufacture of electronic thermometers. To achieve the goal, the following task must be solved. First, analyze the thermometer from the point of view of their stability for monitoring temperature fluctuation of the surface of a biological object. 2. Investigate it and dependence for the resolution of thermometers of different temperature range. 3. Determination of the dependence of the speed of the thermometer on the mass of the sensors. And 4. The study of thermal resistance of the produced as an important of the characteristic effects of the international salt.
Valentin, sorry for interruption. You don't switch your slides. We hear only your title slide. Oh, sorry.
So we don't see my presentation.
Oh, we see your presentation, but you don't switch your slide already. Now we see the second slide.
Yes.
Yes, second slide. Now, in the third three slides, we can see the common types of electronic thermometers are contact thermometers. There are three subclasses of contact electronic sensors. This is resistance thermometers, semiconductor thermometers, quartz thermometers, and thermometers based on the thermocouples. We can see in the figure 1. Now, in the table 1, listen common temperature sensor and their features. We can see this thermocouple, RTD, thermistor, semiconductor sensors, and quartz thermometers. We have range, high accuracy, and reproducibility, requires voltage comparison on cold junction, and low voltage output for these classes. So let's consider existing serial thermometers from the point of view of their suitability for monitoring temperature fluctuation on the surface of a biological object. We will analyze the technical parameters and the characteristics such as speed and resolution. The most important quality indicators of various thermal sensors taken into account their use in a narrow temperature range are listed in the table 2. The symbol 3+ indicate a high level of suitability for their parameters. 2+ and 1+, respectively, mean and low. From the comparison of the given parameters of the transduced, it can be concluded that the most suitable for the mentioned purpose are semiconductor diode transduced in package design, which have a higher speed. It should be known that pyrometers also have high speed, but their disadvantages include low sensitivity and high cost. now we can see for table 2 quality indicators of temperature sensors. In slide 5, we can see that the resolution of thermometers is related to its transmission coefficient, since the output voltage of the operation amplifier is limited to the range of 310 volt and is a constant value. Expanding the range of measurement temperature leads to decrease in the transmission coefficient, and vice versa. A decrease in the range leads to an increase in the slope by the same number of meters. It is important to know that with a limited maximum output voltage on the thermometer, there is a constantly or reproducing the range of control temperature delta T by the temperature to voltage conversion factor U degrees. The specified dependence of the steepness of characteristic for different temperature range is shown in the figure 2. You can see in this slide. Now, the output signals of the thermal sensors different in their conversion function, so thermocool conversion temperature into voltage and thermosensitive sensors change their resistance when the temperature change. There are two types of thermistor with positive and negative temperature coefficient of resistance. Semiconductor diodes sensors are characterized by a decrease in direct voltage when the temperature increases. An evolution of the coefficient of informativeness of temperature conversion of contact thermal sensor in proposed in table 3. The information obtained as a result of measurements is quantitative and serves to evaluate the quantitative data about the studied object or phenomena, regardless of their natures, obtained with the help of chain. Receiver object, measuring device, and the receiver. In our case, Hartley logarithmic measure was used to characterize the quantitative information. Informativeness of the initial parameter in the temperature range of 20-40 degrees percent. Now, it was establishment that the speed of thermometer is determined by the mass of the sensor, since it is by the value of the thermal time contact. Errors illustration this relationship figure 3 for some types of sensors, sensors in different types of package. Figure 4. For example, temperature voltage converted by microchip in a DESSERT'2023 package, a thermal sensor by SmartTech in a TO18 package, thermistor on the NTC company in the DO35 package, of the National Semiconductor company in the TO82 package, and of the Hygress company in the SO8 package. Thermal time constants term in still air for the housing of semiconductor sensors depending on their mass are shown in the figure 3. For high-speed thermometry, it is necessary to use sensor with a minimum mass, in particular packaged semiconductor diodes and transistors. The second important factor of the sensors which characterize the effect is international self-heating is thermal resistance. Figure 5 show date on the relationship between mass and thermal resistance of several common time of the integrated circuit housing. And conclusions. From the analysis of Figure 4, it follows that for monitoring temperature oscillation of the body surface, the most efficiently are caseless semiconductors, diode, and transistors. Temperature sensor with a thermal time contact in the range of hubless of a sensor and a thermal resistance of 2.5 degrees per milliwatt. As a sensitive elements, it is recommended to choose a caseless diode photon or transistor. The dimensions of which do not exceed 1 millimeter with a mass of up to 0.5 grams. As the mass of the sensor decreases, the mass of the thermometer itself decreases, which has a positive effect on the thermal time contacts and therefore increase the speed of the device. To ensure high sensitivity in the temperature range of 20-40 degrees, a diode sensor should be used in the mode of operation with a contact voltage with an output temperature dependent parameters of the diode current. The specified mode of power supply of the diode ensures that temperature sensitivity of the sensor is 5 times higher than when powering the diode with direct current, and the output parameter in the form of direct voltage. So sensors based on semiconductor diode provide high speed, short response time, and operation in the mode of microcurrents, which would maximally reduce the self-heating and the sensor which sensitivity, good linearity, and in a given temperature range 25 40 degrees, stability of electrical parameters. I am conclude. Thank you for your attention.
Valentin, thanks. Colleagues, please, questions. Does somebody have questions? Okay, if no, I will ask one question. At slide 7, you said about some measure called Hartley logarithmic indicator. What is this? Can you explain? Valentin, have you found?
Yes, sorry. Maybe repeat the questions. You might repeat the questions.
Yes, at slide 7 in its lower part.
Yes.
You said about some Hartley logarithmic indicator or measure. Can you please explain what is this? Have you found?
Yes, in slide 7. This slide.
Yes. You see Hartley logarithmic measure. Say Hartley's logarithmic measure was used to characterize. What is this?
We can present formulas logarithmic measures. This formula we can see in our publication. I don't present this. Yes.
Mhm. Okay, and can you say why have you used it? Is it a typical measure? Maybe it was some specific measure just for your purpose.
Specific measure with include temperature of temperature of semiconductors. Temperature of semiconductors diode. So sorry for my English. I very hard answer the question in English.
Okay, I will try to look in the paper.
Yes, thank you.
Okay, does anybody have some other questions? Okay, then, Valentin, thank you one more time. And I will ask presenters not to take away the presentations just after presenting them, because somebody might have questions just to certain slide. Okay?
Okay.
So
Thank you for your attention.